Welcome to the channel. In this video we are going to discuss limits and continuity, important problems for intermediate final examinations. So here the question is given: compute limit x tends to 0 cos ax minus cos bx whole divided by x square. So now in the solution, given that limit x tends to 0, limit x tends to 0, cos ax minus cos bx whole divided by x square. So here if you observe in the numerator, it is like cos c minus cos d. Cos c minus cos d, we have the formula cos c minus cos d, which is equal to minus 2 sine c plus d by 2 into sine c minus d by 2. So now here, which is equal to limit x tends to 0. So it is like cos c minus cos d. What is c here? Ax is c and bx is d. So cos c minus cos d is equal to minus 2 sine c plus d by 2 sine c minus d by 2. So that's why here minus 2 sine c plus d by 2, that is ax plus bx by 2 into sine c minus d by 2, that is ax minus bx whole divided by 2 whole divided by x square here. Now here, which is equal to, so limit x tends to 0, limit x tends to 0, and this is minus 2 into sine of, this can be written as a plus b by 2 into x. This is it. When you take x common, we can write a plus b by 2 into x into, so this is sine, so a minus b by 2 into x whole divided by, so x square here. So now we can write this is equal to minus 2 into, minus 2 is constant, minus 2 into, so limit x tends to 0. So this can be written as sine a plus b into x, a plus b by 2 into x by, here x square is there, that is writing as 1x into again limit x tends to 0, and here sine a minus b by 2 into x, so whole divided by, so in this denominator x square can be splitting for both the functions. We can split for both the functions. Then it becomes minus 2 into limit x tends to 0 sine a plus b by 2 into x by x into limit x tends to 0 sine a minus b by 2 into x by x. See, observe here, we have one of the standard form of the limits. So that is, so here limit x tends to 0, limit x tends to 0 sine kx, sine kx by x, sine kx by x, which is equal to here, so k, we have the standard form of the result here. So limit x tends to 0, sine kx by x is there, so which is equal to, we can write here the value of this is here kx, k, that is equal to k. So same like that here, minus 2 into limit x tends to 0 sine a plus b by 2 into x by x, here which is like sine kx by x. So what is k here? A plus b by 2 in the first case. In the next element, what is k here? A minus b by 2. When you compare these two limits with limit x tends to 0 sine kx by x, then we can write which is equal to minus 2 into, so this is, so a plus b by 2 here, The first limit is a plus b by 2 into the next limit is here a minus b by 2. Next limit is a minus b by 2. Now here 1 2 gets cancelled. So now which is equal to minus 1 by 2. This is like a plus b into a minus b. So which is nothing but a square minus b square. When you multiply this is with minus. So finally what we can write, this is 1 by 2 into. So this is a square minus b square becomes b square minus a square. So that's why 1 by 2 into b square minus a square or b square minus a square by 2, which is the final solution.